Okay, so we have our test tomorrow over ratios, rates, proportion, and measurement conversion. So let's go ahead and look at our review. Question number 1 can be found on page 24 because this is technically a unit rate problem. So we're talking about his typing rate, and I'll talk about why that's a unit rate in just a minute. But we do know how many words he can type in 6 minutes. So 258 words in 6 minutes. We want to know his typing rate. So first of all, let's go ahead and set up a box here because we're talking about how many words in how many minutes. And they've given us a rate of 258 in 6 minutes. Now his typing rate, if we look at our answer choices, we know is either going to be words per minute or minutes per word. Only one of those really makes sense. So I want to look at this first one, 1,548 minutes per word. 1,548 minutes is a long time. 60 minutes is an hour. So we're talking about hours here. And that's how long it takes him to type one word. It says per word, no S on the end. So that's just one word. Why would it take him that long to type a word? Even if we went with the other one that says minutes per word, 43 minutes. That's almost an hour. It's the better part of an hour to type one word. We know he's typing this many words in 6 minutes. Why would it take him 43 minutes to type just one word? So these ones that say minutes per word don't really make sense. Your typing rate is how many words you can type in 1 minute. So per minute, 1 minute. So that's why we're going to put a 1 there. Remember that unit rate always has 1 unit as the second quantity. So it's either 1 word or 1 minute. But we just talked about why the 1 word ones don't really make sense. Once you have your box set up, then we know we can go from the 6 to the 1. Anything divided by itself is 1. So all we have to do to find his typing rate is divide the 258 minutes by 6. 6 can't go into 2. It can go into 25 4 times. 6 times 4 is 24. We subtract and get 1. I bring down the 8. 6 goes into 18 3 times. That is 18, and we subtract and get 0. So we know our answer is C, 43 words per minute. If we look at A, 1,548 words is a lot of words. He wasn't typing that much in 6 minutes. It doesn't make sense for him to be able to type more words in 1 minute than he did in 6 minutes. We should be dividing that 6 down to get the 1 minute. Okay, so that was answer choice C. And now let's look at question number 2. They've given us a ratio here, the ratio of right-handed students to left-handed students. Okay, so remember that in ratios, order matters. So I would keep it in that order, right-handed students to left-handed students. You notice that I'm putting this in the box. That can be found on page 23, how to solve proportional problems with the box. So this is a proportion problem because they're giving us a ratio. They're saying right-handed to left-handed is 3 to 2. Then they're giving us this other number. They're saying there's 90 left-handed. We want to know how many right-handed students there are. So I'm going to put a question mark there. That's what they're asking us for. And so remember that our ratio goes here. We already have our labels, so our ratio goes here. And because it said right-handed to left-handed is 3 to 2, if we keep it in that order, we keep the 3 to 2. And then it's 90 left-handed, so that has to go down here with our left-handed label. We're looking for the right-handed ones. That's why that one's empty, because that's going to be our answer. So remember, to solve the box, we need to cover up our diagonal numbers. That tells us we're going to start our relationship from the 2. I could go either this way to the 3 or this way over to the 90. But I know there's nothing I can multiply 2 by that's going to give me 3, which means I need to go this way. 2 times something equals 90. Now, some of y'all, when we do problems like this, I see y'all counting on your fingers by 2s all the way up to a big number like 90. That's really not the best option here. I would work backwards. If 2 times something equals 90, divide 90 by 2, and that's going to give us our answer. 2 goes into 9 4 times. 2 times 4 is 8. We subtract, we bring down. 2 goes into 10 5 times. So we know that 2 times 45 is 90. That was a lot quicker than trying to count by 2's all the way to 90. Okay, now we want to draw our matching arrow. So because that one said times 45, our matching arrow also says times 45. Again, best to just work it out. 45 times 3 is going to give me 135. So that means there would be 135 right-handed students. Okay, next problem. Again, we're talking about ratios, but this time they're giving us tables, and they want to know which table represents the ratio. So we're talking about a ratio of sugar to butter, and you notice they all say sugar to butter in the tables. The ratio is 1 to 2. They all start with 1 to 2. If you struggle with ratio tables, you do have notes on page 22 about these. But remember that ratio tables are kind of like the box, but just with more numbers. So you're still looking for relationships. So for instance, if I look right here, 1 times 2 is 2, but 2 times 3 is 6. Those don't have the same relationship, so I would get rid of B. Right here, we see 1 times 3 is 3. But 2 times 6 is 12. Again, those don't have the same relationship. Our arrows have to be matching, so that won't work. On this one, 1 times 2 is 2, and 2 times 2 is 4. So that part works. I'm going to come back to the other one in a second, because I also see that 1 times 5 is 5, and 2 times 5 is 10. So that one works too. A lot of people, they make the mistake of just looking at the first relationship, and if that one works, they choose that. But we see here that we have 2 where that first relationship works. So we have to also check this third column, and you might have a table with even more. Here, I'm going to look back to my original number. So 1 times 6 is 6. 2 times 6 is not 8. 2 times 4 is 8. So that relationship and that relationship are not the same. But if we look over here, 1 times 6 is 6, and 2 times 6 is 12. So that one does work. We also could have looked at the relationship here. We could have said, okay, 4 times 2 is 8. 2 times 2 is not 6. 2 times 3 is 6. But I want you to be able to go back to the original one, because like right here, there is no relationship. We also could be going the other way on these. 1 times 2 is 2, 5 times 2 is 10, 6 times 2 is 12. Not all tables have a relationship going that direction, but if your table does, you can use that way too. So just like the box, our arrows can go up and down or side to side, but you're looking for that relationship to be consistent on both sides. Question number 4 is about measurement conversion. You can find notes about this on page 25. So we're looking at Michael's pencil. It's 13 centimeters long. We want to know how long that would be in meters. So I underlined my 2 units. Just like the regular box, we want to start by labeling our units here. And then remember, there's only one number in this problem. We need 3 numbers to solve a proportion. So we have to get the first 2 numbers from the chart. So the star chart has all our conversion rates on it. And that star chart is going to tell me that 1 meter is equivalent to 100 centimeters. And then the problem has 13 centimeters. Now be careful, because what a lot of people do is they look at this and they just make an assumption that they're going to multiply by 100. But we can't assume, because remember, sometimes we're dividing. You have to still cover up your diagonal numbers. So we know we have to start at 100. And I can't do anything to 100 to get 13. So I'm going to go this way. 100 divided by 100 is 1. So we're not multiplying by 100 here. We're actually dividing by 100. And I'm just going to quickly remind y'all about the trick about moving our decimal point. So if I wanted to multiply times 10 or times 100 or times 1,000, I could move my decimal point either 1, 2, or 3 times to the right. We don't want to multiply here. We actually want to divide. So remember, if I wanted to divide by 10, I can move it 1 time to the left. If I wanted to divide by 100, I can move it 2 times to the left, which that is what we want to do. And if I wanted to divide by 1,000, I can move it 3 times to the left. But we want to divide by 100. So if I take the number 13, there is no decimal point. No decimal point, no decimal in sight, put it on the right. And like I said, we want to divide by 100. So if I move it 1 time, that's dividing by 10. If I move it 2 times, I just divided by 100. So this answer choice right here is where people would just assume that we're supposed to multiply. We don't want to do that. This one would only be dividing by 10 because they only moved it 1 time. We don't want to do that. And this one right here, they moved it 3 times. So that would be if we were dividing by 1,000. But B is the one where we divided by 100. So that's our answer there. Question number 5 is about ratios, and this can be found on page 21. I've showed y'all several ways to solve problems like this, so let's talk about a couple of them. So it says for every 5 cupcakes, there are 8 cookies. We want to know which ratio is equivalent. So one of these ratios down here is equivalent to that. One way that's been working really well for some of you is just to make a quick table. So we're talking about 5 to 8 is our original ratio. And then I told y'all just kind of look at, okay, what if I did both of them times 2 or times 3 or times 4 or times 5? I wouldn't go much further than that because our numbers aren't that big. But if I were to multiply both of these by 2, 5 times 2 is 10, 8 times 2 is 16. I don't see that ratio. 5 times 3 is 15, 8 times 3 is 24. I don't see that ratio. I do see a 15 here, but it's not with a 24, so I can already get rid of that one. I can also get rid of this one down here because 5 to 8 and 5 to 9, that can't be the same. If I multiply 5 times 4, I get 20. If I multiply 8 times 4, I get 32. So that I do see. And even if I keep going, my numbers are getting bigger. I've already passed 12. 12 was not one of my options. 18 was also not one of the bottom options. So 12 to 18 can't be equivalent to 5 to 8. So we already know our answer is B. But let me show you one more way to know this. So we also talked about how you could simplify ratios. So if I look at these two numbers right here, I see they're both even, so I could divide them by 2, but I also see they're both divisible by 4. And 4 goes into 25 times, 4 goes into 32 8 times. So there I get my equivalent ratio. And I'll prove here that 12 to 18 is not our equivalent ratio. That one is even, so I could also divide by 2, but I also see that I can divide both of those by 6. 6 goes into 12 2 times, and 6 goes into 18 3 times. 2 to 3 is not the same thing as 5 to 8, so I know that that is not my answer. So the table, like I said, that works really well, but just remember you can also simplify the ratios, and the correct ratio should simplify to your ratio that's in your problem. Okay, question number 6. We've got a ratio table here, but it's going the other direction. Again, ratio tables are on page 22. So we know the original ratio is 2 to 15, hours to dollars. That one is not in the table. So I would add that up here, 2 to 15. That's going to help us here. If you are, like, if this was your test and you don't have the paper, I would redraw the table and I would add in a row for those numbers. Because once you have those in there, I can see right here, 2 times 2 is 4, 15 times 2 is 30. So that's how we've gotten those numbers. Now, 2 times 4 is 8, so we need to do 15 times 4 here. So 15 times 4 is going to give me 60. And then down here, I can look at what could I multiply 15 by to get 90? Well, that's going to be times 6. And then 2 times 6 is 12. Okay. I would be cautious of just looking for a pattern here because sometimes they skip things in the pattern. So you really need to be drawing arrows to figure out your relationship. It has to be the same relationship on both sides. And they're going to give you some, on the test, they're going to give you options. And some of them might be options that if you're not really paying attention, you might think they work. So just make sure you're drawing that table and drawing the arrows. Question number 7 is another proportion problem. And so again, you can find that on page 23 because we set up the box for that. Okay, so we know how much is in the bowl, 24 ounces of water. Then they're giving us our rate here, 3 ounces every 2 hours. So ounces and hours, you get your label from your ratio or your rate, and that was right there. Be careful. A lot of people want to put the 24 right here, but remember, your rate or your ratio goes here. Even if you forget the fact that they said that it's the rate, the numbers here have to be the ones that are together in the problem. 24 does not have another number in the sentence with it, so that is not a part of our ratio or our rate. So we want to put the 3 ounces every 2 hours there. Then it's 24 ounces. Make sure you put that in the right spot because it's not 24 hours. When I cover up my diagonals here, I know that I have to start my relationship from the 3. I can't do anything to 3 to get 2 because 2 doesn't go into 3 evenly. But I do see a nice relationship here. 3 times 8 is 24. So we're going to draw our matching arrow, and 2 times 8 is 16. So it would take 16 hours for all of that water to evaporate. Okay, we've made it to the last question. How many inches are there in 8.5 feet? So this is another measurement conversion. We're going from feet. They gave us feet. We want to go to inches. So I'm going to start by putting in the 2 units that they gave us, inches and feet. There's only one number. Remember that your other 2 numbers, the ones that you're going to put here and here, have to come from the star chart. So the star chart tells me that 1 foot is equivalent to 12 inches. And then we have 8.5 feet here. So if I cover up my diagonal numbers, I know I need to start from the 1. I could either go this way, I could do times 8.5, or remember you can also go up. So I'm just going to say times 12 here, and then 8.5 times 12. Be careful because the other day when we were doing our multiplication, and if it included a decimal, some of you were forgetting to put the decimal in your answer, and that's going to make you get the problem wrong. So let's go ahead and multiply. 2 times 5 is 10. 2 times 8 is 16, plus 1 is 17. Placeholder 0. 1 times 5 is 5. 1 times 8 is 8. Okay, so what I was saying was some of you were getting down there, and you were just leaving that as your answer, and you were trying to figure out, well, why is that wrong? Remember that if there's a decimal in your problem, there has to be a decimal in your answer. And so we have to draw our little swoopies so we can figure out where it goes. So there's 1 in the problem. That means there's going to be 1 in the answer. So it's not 1,020, it's 102. Big difference. So 102 inches for that one. Okay, I hope that this makes sense. If you need to rewatch this, please do. Also, if you need to watch any of my other videos, I did send those out to your parents. They're also on the YouTube channel and attached to all of your assignments for this unit. I want you to be successful tomorrow, so make sure that you are preparing yourself. Good luck.